Okay, sketch the region bounded by the graphs of the algebraic functions and find the area of that region. All right, so we have two functions here. So the first step is to sketch the region that we're trying to find the area of. So this is actually really easy to do if you know your common graphs. The first one, the cube root of x, is a line down disco curve. So I'm going to go ahead and sketch that. And then the next one is just a line with a slope of 1. I'm going to do a better line there. That's not the best line. That looks a little better. Okay? And so you have this line, and you have this line down disco curve, and then I want to find the area bounded by the graphs of these two functions, which gives us an enclosed area, and we're looking for the area of that enclosed region, which would be this section here. Okay? And then this section here. Now the way we've learned to do this is we know that we can use a definite integral where we take the top function minus the bottom function. And the reason that works, in the first quadrant it's really easy to see, because if I find the area under the top function, which is the cube root of x, it'd be all this stuff in red, and I'll just kind of draw it with lines here. It'd be all this area in red. And then if you find the area under the line, it'd be all the area in blue. And if I go the area under the curve of the top function minus the area under the curve of the bottom function, you're going to end up with the black stuff. Because you take the red minus the blue, you subtract out that white part, or that gap there, and then you end up with the blue area. Over here it doesn't seem like as logical, but it's the same thing. You still go top minus bottom. And if I think about it, the top function again, here would be the line this time. So that'd be all this area here, which is a negative area. So it'd be all this area, all the way to the end. Okay? And then the other area, which is the area under the disco curve, that would be the bottom function. And if you do that one, same thing. And it's still a negative area. And here's what's interesting here. If you take a smaller negative area and subtract a bigger negative area, so a small negative area minus a bigger negative area, and this is small, and this is really big, you're going to end up adding the big one, which is going to end up with a net positive area, that black area, which is really what we're after there. So what I have to do at this point, I guess I could have left all that, but I'm just going to get rid of it so you can see it, is I need to just figure out what these points of intersection are, and then I can find the area from this point to this point, taking top function minus bottom function, which would be g of x minus f of x. Then I can do the same thing from here to here, top function, which would be the square root of x, minus the bottom function, which would be the line. And then what you might also notice here is that another way to do that, well, we'll get to that in a minute. Let me just do it this way first, and then you and I can consider another way that you might do this problem. So I need to find these points of intersection, so I'm going to take the cube root of x, this function, and figure out where they cross. I'm going to set them equal to each other. So I'm going to have the cube root of x equals x. I'm going to cube both sides. So we're going to get x equals x to the third. Then I'll set it equal to 0. So I'm going to move the x over. So I get x to the third minus x equals 0. Factor out an x. You get x squared minus 1. So you get two solutions, x equals 0 and x equals plus or minus 1. So then I'm going to have the area be represented by taking the definite integral. So over here is obviously the -1, the 0, and then the 1. So this is everything's in terms of x, so my limits of integration have to be in terms of x. So it's going to be -1 to 0 of the top function, which is x, minus the bottom function, the cube root of x dx, plus the integral from 0 to 1 of the cube root of x, top function, minus x dx. So we're going to have 1/2, then we'll rewrite the integral, so we'll have -1 to 0 of x minus x to the 1/3 dx, plus the definite integral from 0 to 1 of x to the 1/3 minus x dx. Integrate, we're going to get 1/2 x squared minus, this is going to end up being x to the, if I had 3/3, that's 4/3. Divide by that, you multiply by the reciprocal, 3/4, and that'll be evaluated from -1 to 0. Then plus, same thing here, this will be, evaluate this one, 3/4 x to the 4/3 minus 1/2 x squared, evaluated from 1 to 0, or 0 to 1.
There's no one else in.
F of b minus f of a. When I do my 0, I'm just going to end up with 0 minus, okay? And then I plug my -1 in. 0 just gave me 0. Then I plug -1 in, I'm going to end up with 1/2 minus, yeah, because -1 squared is 1. 1 times 1/2 is 1/2. -1 here would be the cube root of -1, which is -1. But then -1 to the 4th power would be +1, and then it ends up just being minus 3/4. And then be plus, over here, f of b, plug in the 1 first, you're going to end up with 3/4 minus 1/2. That's pretty straightforward. And then minus 0. And what you should see is that this is end up going to be the same thing twice. If I do this here, common denominator would be 2/4 minus 3/4 would be 5/4, because you got this negative. This ends up being -5/4, and so it would be 5/4 there. And over here is going to end up being the same thing. 3/4 minus 8/4 is going to be, well, 2, so it'd be 1. So it'd be 3/4 minus, multiplied by 2. 2/4, that ended up being 1/4. Let's see what I did here, because this should be the same. 2, oh sorry, this is not right, that's not 5/4. This is 2/4 minus 3/4 is -1/4. That was a mistake, -1/4. So it ends up being +1/4. They ended up being the same. It's 1/4 plus 1/4 is 2/4, which is 1/2. Now, what you might have seen here, this is really cool because you saw these two areas were the same, which means if you were to recognize the fact that these are symmetric about the origin, you would realize that these two areas are going to be identical. So instead of finding both of them, you could have just doubled the area from one of these, from 0 to 1, of the cube root of x minus x dx. And this, if you would have worked this out, would have also given you the 1/2. So instead of doing both areas, you could have just said, well, they're both going to be equal, so I'll just find the area from 0 to 1, find that section, and just double it. And you would have gotten the same answer. So that's what that looks like. And sorry about the phone ringing.